Okay, what we're going to do in this next video is we're going to go to section 2.6, part 1, and we're going to look at solving equations, but we're going to look at solving a second type of equation. In section 2.1, I told you that whenever you solve an equation that has one letter in it, now it may occur multiple times, but one letter and that variable is to the first power, and that's the only variable you have in that equation. That's what we call linear equations. So section 2.1, all of those were linear equations, one variable. Then in section 2.4, we learned how to solve linear inequalities. And then in section 2.5, we learned how to solve a compound inequality. In section 2.6, what we're going to look at is we're going to look at solving absolute value equations. Now, what I want to do first quickly is just remind you what the absolute value symbols look like. Remember, the absolute value symbols in mathematics are the straight bars. So like when you see this, we would say that that's the absolute value of 5. Those are the absolute value symbols. And what that just simply means is this. When you say what is the absolute value of 5, what you're wanting to know is what is the distance, that's what absolute value means, what is the distance from 0 to 5 on that number line. So absolute value of a number is how far that number is from 0 on the number line. So the absolute value of 5 is 5 units away from 0 on the number line. So if I said, what is the absolute value of negative 3? That's asking how far is it from 0 to negative 3. Well, since you're referring to distance, it's 3 units away. So that's why we say, in essence, the absolute value of any number is the positive of that number. That's just a shortcut way to say that, but that's why. So the absolute value of 0, of course, is 0 then. Now, whenever you take the absolute value of something, it can never be negative. So this is not possible. And the reason is because by definition, what absolute value represents. Absolute value represents the distance. Distance can never be negative. Now, absolute value of a number can be 0, and it can be positive, but it can never be negative. All right, in this particular section, we're going to look at what's called absolute value equations. And these equations are equations where your x is inside absolute value symbols. So just to give you a visual of a couple of absolute value equations, absolute value of x plus 3 equals 7, or absolute value of 2x minus 1 plus 4 equal 11. Those are absolute value equations. So this is the problems what we'll be solving. This is what they'll look like. Now, you can't solve these like you do the ones in 2.1, where you just pretend like the absolute value symbols aren't there. So what I've got to do is show you how do we mathematically deal with the absolute value symbol. And what I'm going to do in just a minute is I'm going to show you how to rewrite the problem so that when you rewrite it, you can rewrite it without the absolute value symbols. And I'll show you that in just a few minutes. So when we work this problem, we're not just going to pretend that the absolute value symbols aren't there and just work it. So we've got to deal with the absolute value symbols first. Okay, what I'm going to do is I'm going to give you the steps in solving these problems. I would strongly suggest that you write these steps down as I quote them to you so that you will have them in your notes. So, Step 1, take down this note, title the note, Steps in Solving Absolute Value Equations. Steps in Solving see, I may have that. Steps in solving absolute value equations. Okay, here's step one. Step one says, isolate the absolute value term. So if you need to pause the video, do so. Isolate the absolute value term. So in other words, here's what you want to do. After you finish the first step, you're going to have the absolute value of something on the left side. You're going to have your equal sign, and you're going to have your number on the right side. Step two. All right, write this down. If the number on the right side of the equal, if the number on the right side of the equal is negative, there is no solution. Now, where does that come from? Because of what we said up here. If this is a negative number over here, there's no solution. So step two, if the number on the right side of the equal sign is a negative number, there's no solution. Step three, identify A and B, and use capital letters for those. Identify A and B. I'll explain that in just a second. And rewrite the problem, identify A and B, and rewrite the problem by using the following formula. By using the following formula. And here's the formula. Absolute value of A equal B. Absolute value of A equal B. Now, here's how we're going to rewrite it. A equal B or A equal negative B. And you could put either one of those first. All right, let me point out a couple of things. I know this doesn't make sense yet, but it will. So when I ask you what is A is the stuff that's inside the absolute value symbol. The A, this is where your X is going to be. Now, there may not be just an X. There may be some X stuff in there. We call it an expression with X in it. B in our problems will always be a number. Now, remember, if B is negative, we stop right there and say no solution. But remember, this is step what? This is step 3. So you don't identify A and B until you have done the first step. Now, what did the first step say? Isolate the absolute value term. So you want to get the absolute value stuff on one side and then the number on the other before you identify A and B. For instance, let me just get a little ahead of myself. In this problem right here, if I ask you right here, what is A? A is X plus 3. What is B? 7. But in this problem right here, if you say that this is A, and it is, 2x minus 1. But if you say that B is 11, you would be incorrect. B is not 11. B is what you get after you do step 1. So I would have to get this absolute value stuff on a side by itself first. So the first thing I'm going to have to do is subtract 4 from both sides. When I do, this is going to be 11 minus 4, which means then B would be 7 in that case. So you've got to remember to do that first step. One other thing that I want you to notice, or actually two things, when you use this formula. First of all, when you're solving an absolute value equation, you go from one equation to 2. That means that most of these problems will have 2 answers in it. Not all of them, but most of them will. And you'll see why you don't get 2 answers in the cases when I get to those problems. The second thing I want you to notice when you go from here to here is you don't write the absolute value symbols anymore. So this formula is what enables me to rewrite this so that I can rewrite it without the absolute value symbols. Then I can solve these 2 equations. All right, so what we're going to do is start out and we're going to solve some equations. Do some very simple equations. Okay, so the instructions here, solve the following. Then write the instructions down. Solve the following equations. Solve the following equations. All right, start out here super simple. First, why is this an absolute value equation? Because my x is inside absolute value symbols. So you got to know your 3 steps. Step 1. Step 1 is to isolate the absolute value term on one side. It is. Step 2. Step 2 says if the number on the right is negative, you can stop and say there's no solution. Well, it's not. It's positive. Step 3, identify A and B. This is my A and this is my B. So what I like to do every time on these is I like to write A equal B or A equal negative B. Now, what did we say A was? A is what's in the absolute value symbols. So this will be x equal, and then b is the number on the right side, or x equal negative 4. And there's nothing else you can do to these 2 equations because they are already solved. That is your 2 solutions to this problem. Okay, let's check it. Let x be 4. What's the absolute value of 4? It's 4. But check negative 4. What's the absolute value of negative 4? It's also positive 4. So you don't have to check these, but you can. Okay, let's look at another example. Number 2, absolute value of 2x minus 3 equals to 9. Okay, let's follow the steps. What does step 1 say do? Isolate the absolute value term. That's done. Step 2, if this is negative, it is not. So I can keep going. Go to step 3. Identify A and B. So what is A? A is whatever's inside here. So this would be 2x minus 3 equal 9, or 2x minus 3 equals negative 9. Now I have broken up the problem into 2 equations. Now here's what makes this one different. This is not solved, nor is this. The reason is because the x is not by itself. Now don't put absolute value symbols here. But I've got to go on down now and solve these 2 equations just like we did in 2.1. So I'm going to add 3 to both sides. When I do, I get 2x equals to 12. Divide by 2 to get x equals 6. But we have another equation to solve. Add 3 to both sides. So this would be 2x equals 2. This is 2 times x, sorry. Negative 9 plus 3. So this is 2x equals negative 6. Divide by 2 to get x equal negative 3. You do not have to check these, but I want to show you, just to show you that both of these do work. Let's let x be 6. What's 2 times 6? 12. 12 minus 3 is 9. And then what's the absolute value of 9? It's 9. So that works. Now let x be negative 3. 2 times negative 3 is negative 6. Negative 6 minus 3 is negative 9. But if you take the absolute value of negative 9, you get positive 9. So both of these solutions here do work. So just use the formula, but you got to remember the 3 steps. Okay? Let's look at example 3. Absolute value of 4x minus 3 minus 7, or let's say plus 7, equals to 7. Okay, here we go. Step 1. Isolate the absolute value term on a side by itself. Now, this is the absolute value term. It is not on a side by itself because of that adding 7. You can't add this 7 in with this negative 3 because this is absolute value bars. It's not like parentheses. So the first thing I've got to do is I've got to get this on a side by itself. I do that by subtracting 7 from both sides because that's a plus 7. If this was a minus 7, I'd add 7 to both sides. When I do, this adds out. The absolute value symbols are still there. I'm not using my formula yet. This is just step 1. The right side is 0. That's step 1. Step 2, if this is negative, it is not. So keep going. Step 3, identify A and B. So this would be A equal B or A equal negative B. So A is what's inside the absolute value symbols, which is 4x minus 3 equals 0, or A is what's inside absolute value symbols, 4x minus 3 equal negative 0. Now, if you stop and think about it, you know that 0 and negative 0, are there any differences? No. 0 and negative 0 is the same thing. Now, 5 and negative 5 are not the same. So what's going to happen is, when I solve this equation, add 3 to both sides. So I get 0 plus 3. You get 3. Then divide by 4. X equals 2 3/4. Now, what's going to happen when I add 3 to both sides here? Negative 0 plus 3 is going to give you 3 again. So what's going to happen is basically you're just going to get the same answer twice. So you say, well, Mr. Rayner, is it going to be true then that any time that B, after you do step 1, if B is 0, will you always just get one answer? Yes, that is correct. So you don't have to enter the same answer twice. Just enter the answer 3/4. It's two answers, but it's what I call in mathematics twin solutions. There's other words for it that we use, but that would be the easiest one for you to understand. It's the same answer twice. So you basically only get one answer. So if B is 0, you'll get one answer after you isolate, after you do step 1, and if B is positive, you will always get 2 solutions. Okay, let's do one more example to close out this section. Absolute value of 7x plus 3 minus 8 equals negative 11. Absolute value of 7x plus 3 minus 8 equals negative 11. Now remember, stay within your steps. Don't get ahead of yourself. Step 1, isolate the absolute value term. Here it is. It is not by itself. I have to get rid of the subtracting 8. I cannot add it with this number. So to get rid of the subtracting 8 that's outside these symbols, add 8 to both sides. So now I've got absolute value of 7x plus 3 equals 2, still absolute value symbols there. Negative 11 plus 8 is negative 3. So that's step 1. Now, step 2. Step 2 says, if B, which is right here, if it's negative, it is, there's no solution. You stop right there. If you do anything else from this point, and that's the symbol for no solution, if you do anything else from this point, it's wrong. Because this is negative. Now, if I had added 8 to both sides and this would have been a positive number, then I'd call this A, this B, and write A equal B or A equal negative B. So if that is negative, after you isolate, there is no solution to the problem, and you're finished with this problem. because absolute value can never produce a negative answer. Okay, that concludes section 2.6. This concludes all of our chapter 2. And so what we're going to do in our next videos, we will move into chapter 3 and talk about equations now with not just one letter, but equations with 2 letters in the problem. So that will be our next video, and that will be chapter 3, section 1, part 1. There is no part 2 to section 2.6.